So this is a solution for number 28 in the PPB. A crane is lowering a box of mass 50 kilograms with an acceleration of 2.0 meters per second squared. We're going to find the tension in the cable that connects the crane to the box. So we were going to start with our 5-step process, draw and label the picture. I'm going to just go right ahead and do the free body diagram. The first thing I'm going to do is indicate the acceleration, which is downwards, 2 meters per second squared. And that tells me that the tension up has to be less than the force of gravity down, because the net force is in the direction of the acceleration, and the net force is the imbalance of the forces. Step 2 is to write Newton's second law, sum of the forces is equal to ma. And now our job is to understand what the expression for the sum of the forces is. I'm going to choose down as positive and say that Fg minus T is equal to ma. And from that, I can solve the equation for T, Fg minus ma. And then for part 3, I solve for the tension by plugging in the numbers and checking my units. This is a sort of abbreviated version of the 5-step process. I'm doing this in 3 or 4 steps. The force of gravity here is the weight, which hopefully you remember is mg. So the tension is equal to mg minus ma. The mass is 50 kilograms. G is our old friend 9.8, which I'm going to say is 10 newtons per kilogram, minus 50 kilograms again times my acceleration, which is given to be 2 meters per second squared. And then we do this out, we get 500 minus 100, or 400 newtons of tension in the cable. Put it in a box, check our units, we have newtons and newtons. For part B, if the crane lowers the box at a constant speed, what is the tension in the cable? Well, for step 1, we're going to do our free body diagram. A is equal to 0, so I have no imbalance in the forces, so the tension up is equal to the force of gravity down. Step 2, I write the sum of the forces is equal to ma. So I say Fg minus T is equal to ma. And then for 3, I'm going to plug in A is equal to 0 to my equation here, which then tells me that Fg minus T is equal to 0. Therefore, the tension in the cable is equal to the weight, which we calculated in the previous example to be 500 newtons. Problem 2. This is number 29 in the PPB. A rocket of mass 10,000 kilograms is accelerating upwards from its launch pad. The rocket engines exert a vertical force of 3 times 10 to the 5th newtons on the rocket. Calculate the weight of the rocket. So let's think about what we know about weight. Weight is the force of gravity on a mass in Earth's gravity field. So I have the mass, 10,000 kilograms. I know that my gravity field on Earth is 10, or 9.8 newtons per kilogram. So this is 1 times 10 to the 5th newtons of weight for the rocket. We're going to draw the free body diagram of the rocket, and we just want to make sure that we indicate that the acceleration is upwards, which means that the up force, which we'll call the F external or F applied or F thrust, is greater than the force of weight because the acceleration is upwards. Calculate the acceleration of the rocket. We say Newton's second law is our first step. We'll say the sum of the forces is equal to ma. The sum of the forces here would be F external minus Fg is equal to ma. And then from there we can say that the acceleration is the external force 3 times 10 to the 5th newtons minus the weight, which we calculated in part A of 1 times 10 to the 5th newtons divided by the mass, 10,000 kilograms, which is going to show up in your calculator, if you do that correctly, to be 20 meters per second squared.